Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to demonstrate how to calculate what's called the Coulomb force on a pair of charges, or on a pair of charged particles. So what we're looking at here, we have a positively charged particle that I'm going to call Q1 here, where Q1 is 3 microcoulombs. Micro means 10 to the minus 6. I'm going to write that off to the side. And over here we're looking at a negatively charged particle here with a value of negative 2 microcoulombs. And again, the micro means 2 to the minus 6. And in this example, we're going to assume they're separated by 1 meter, and we're going to calculate the force exerted on each other. Now, I gave this problem a little bit of color just so it's nice to look at. I don't want you to think in any way, shape, or form that the color red is associated with positive charges or the color green with negative charges in any way. Those are just colors I attach so that to give the problem a little aesthetics, make it a little more pleasing to look at. Now, first of all, let's talk force directions. Because one is positive and one is negative, the force between them is going to be an attractive force. So I'm going to go ahead and draw one force vector here and one here. Now, in this case, I've drawn these forces kind of in as if they're pushing, so to speak. Remember, forces have what's called a line of action. This force vector here, I can draw it anywhere I want along this line. Same thing with this one. Whatever that force is here, it's going to be the same here. That's Newton's third law. Forces always appear in pairs, equal magnitude, opposite direction. And this force, if we treat this like a pair of point charges, we can calculate using Coulomb's law, which says that the Coulomb force acting on a particle is equal to K times Q1 times Q2 over distance squared, where the Q's are the charges on each particle. So I'm going to go ahead and write that out. All right, K is known as the Coulomb constant. 9 times 10 to the 9th Newton meter squared over Coulomb squared. And again, if you look in the text, a lot of textbooks that'll probably read 8.99 times 10 to the 9th. I find it just shorter, easier, and very little error to just say 9 times 10 to the 9th Newton meter squared per Coulomb squared. Okay, the charge Q1 is 3 microcoulombs. Micro means 10 to the minus 6, so that's going to be 3 times 10 to the minus 6 coulombs. Times, all right, Q2 is minus 2 microcoulombs. I'm just going to put 2 here and explain why in a moment. So that's going to be 2 times, I'm sorry, back up. 2 times 10 to the minus 6 coulombs. And that's going to be over the distance of 1 meter squared. Let me talk about why the minus sign was not included. All right. So the plus and minus signs on charges dictate the force directions. Once this force is drawn to the left, we don't need it in the calculation. We know that the force is to the left. All we need is the magnitude at this point. So there's no minus sign is needed here to determine the direction. Right? Basically, once this force is drawn to the left, this minus sign has already been used. Now what we'll do is we'll go ahead and calculate a value. Now, when you're working these Coulomb law problems, I think it really pays to study these carefully. If you just kind of blindly go through and hit all these things in your calculator, there's a lot of buttons to hit. All right, 9 times 10, if you count the buttons, 1, 2, 3, 4, you'll need a power button and then a 9. There's 5 buttons here, like 5, 6 more here and here. You got like 20, 30 buttons you're going to hit. The probability of getting through all of that without making a mistake is reasonably low, at least if your fingers are as clumsy as mine are. So what I advise people to do typically is separate this off. Let's look at the easy numbers and the powers of 10. I'm going to circle these in blue, all right? The 9, the 3, the 2. Most people can multiply those out in their head. If they can't, use a calculator. 9 times 3 times 2, I believe, is 54. 27 times 2. So this is going to be 54 times, now what I'm going to do is I'm going to do the powers of 10 in my head. 10 to the 9th times 10 to the minus 6 is 10 to the 3rd. Times another 10 to the minus 6 is 10 to the minus 3rd power. And this is divided by 1 squared. So I'll just put this divided by 1 squared in the bottom. And unit-wise, when we take Newton meters squared over Coulomb squared, the Coulombs squared cancel, the meters squared cancel. We're left with newtons out of this. So this product should be 54 times 10 to the minus third newtons. 10 to the minus 4 means shift the decimal 3 to the left. So that's 0.054 newtons. So I think what I'll do is just end this video here. It's just intended to be example number 1. But I do think it pays to learn how to separate off the numbers like the 9, the 3, the 2, and the 1 squared, and do the powers of 10 in your head. Typically, most students can do them faster and more accurately than typing them in on a calculator. All right, hope this video helps with how to do these calculations. Have a great day.